So this is problem 1288 from your textbook. So for this one, we have someone that's throwing a basketball into a basketball hoop. It tells us to neglect the size of the ball and determine the magnitude V sub A of the basketball's initial velocity and its velocity when it passes through the basket. So what I typically do with these, looking at page 42 in your textbook or just at the equations for projectile motion, you can take a look at these. So with these, if we go through each of the equations, we don't know, we know a little bit about the direction of V sub A. We know it's at that 30-degree angle. We don't know the initial velocity, so the velocity at A. We don't know the velocity at B, and we don't know the time. And so we're going to have to use multiple of these equations to solve this. So let's just start with the horizontal direction. We have x equals x naught plus v naught in the x direction times time. So x, let's just call this x. We're just going to call this at point A as x is 0. So x is going to equal 0 plus that initial, so that v sub, we'll call it v sub A in the x direction. And v sub A is going to, or in the x direction is just v sub A times the cosine of 30 degrees. And then that's times the time. And we actually do know the x, right? Because x is 10 meters. So that was given in the photo. So I'm going to write 10 meters for that. So we have some relationship here between VA and T. So let's just leave that here for now. Or I'll rewrite it. Let's see. Oh, this is fine. We'll just leave it here for now. So we have one equation with two unknowns. We don't know VA or T. Let's see. If we look in the vertical direction, we have y. We can do an equation that has to do with the velocities. So the final velocity in the y direction equals the initial velocity plus acceleration times time. So that introduces a third variable we don't know, which is that final velocity. Let's see, the second one is the y equals y naught. So we do know the y's plus v naught y times time. So we know that down to the v naught plus 1/2 acceleration times time squared. So that just has that v sub A and T as the unknowns. So let's solve that one. So y equals y naught plus v naught in the y direction times time plus 1/2 A sub C times time squared. So y, the final y is at 3 meters. That equals the initial y, which is 2 meters. That equals 2 meters. Plus that v naught sub y is VA sine 30 degrees times time plus 1/2 times that negative 9.81 meters per second squared. That's just acceleration due to gravity using meters and seconds times time squared. So now we have a second equation that relates the velocity and the time. Actually, let's just move this over here. So we have two equations and two unknowns, so we can solve these now. So let's do, let's take that equation 1 and put VA in terms of T. So I'm going to bring this down here. So VA equals 10 divided by the cosine of 30 degrees times time. Yeah. And then we can just plug that into 2. So now we get, let's see, I'm going to reduce this a little bit. So the 3 meters minus 2 meters is just 1 meter on the left equals, and we're substituting this in for VA. So 10 meters divided by cosine of 30 degrees times time. That's that VA times sine of 30 degrees times time. Oh, my hand hit it. Minus 1/2 of 9.81. That's 4.905. 4.905 times time squared. So then we reduce that. Sine over cosine is just tangent. So we get, I'm just going to move this over to the left since it's just numbers now. So 1 meter minus 10 meters times tangent of 30 degrees, and those times just cancel out. That equals minus 4.905 times time squared. So we can reduce that further. So 1 minus 10 times the tangent of 30. That equals negative 4.7735. And then I'm going to divide that by that negative 4.905. That equals time squared. So time equals the square root of that 4.7735 divided by 4.905. So that gives us 0.9865 seconds. So let's see, that was yeah, let's see, 4.905. That was meters per second squared. And then we see, this was, I'm just looking at our units, meters per second squared. And this over here was meters. So that was meters divided by meters per second squared. So the meters canceled out, and that would give a second squared on the top. Is here, second squared, and then the square root of that gives a second. So I was just checking the units to make sure this works out. So that equals the time. Cool. So now that we've got that, let's see, what all were we looking for? We wanted to find VA and VB. Now we have the time, so now we should be able to find that VA and VB. So let's go back to our equations. So I say go back to our equations. Actually, VA we can go ahead and solve now because we can plug that time back into that equation too. So VA equals 10 meters divided by cosine of 30 degrees times that 0.9865 seconds. So VA is going to equal 11.705 meters per second. And see the meters per second, so that works out. So that's one of the things that we needed to find. So VA. And then we also need to find VB. And so we need to go back to our equations because we haven't done anything with VB yet. But if we look in the y direction, we have VB in the y direction equals VA in the y direction plus the acceleration, the constant acceleration times time. So VB in the y direction is going to equal, let's see, it's going to equal VA in the y direction, which is 11.705 meters per second. And the y component of that VA, let's go back up to our drawing. That y component of VA would be VA times sine of 30 degrees. So sine 30 degrees plus, and then it's negative 9.81 meters per second squared. Acceleration due to gravity goes down, and then times the time, which we found to be that 0.9865 seconds. So the seconds cancel out, so we get meters per second for both of those. So we get, just calculate it out. I get negative 3.825 meters per second, which makes sense. So it should be going down in the y direction. And we also need to know the VB in the x direction. So VB in the x direction, so we know there's no acceleration. So the VB in the x direction equals VA in the x direction, which equals that 11.705 meters per second times the cosine of 30 degrees. It's just this here times the cosine of 30 to get that x component. And so we get VA, or sorry, we're trying to find VB sub x. VB sub x equals, and I'm just going to calculate that out, equals 10.137 meters per second. So that's VBX, we have that VBY. And so the velocity at B is going to equal the square root. So we basically have, at point B, VBY, which is at 3.825 meters per second. VBX is at 10.14 meters per second. So we just want to add those two vectors together to get our VB. So it's just the square root of both of those squared. So the square root of 3.825 meters per second squared plus the square root of that 10.137 meters per second all squared. And so that'll give us that V sub B. That gives us 10.83 meters per second. And let's see, so we have VA and VB, and then I guess we know, yeah, that's VA and VB. We could also determine the direction of that VB, and maybe we should do that also. So this theta here, so tangent of that theta would equal SOHCAHTOA, so opposite over adjacent, so that'd be that 3.825 divided by 10.14. Those are each meters per second. So these cancel out. So theta equals 3.825, 10.137. Gives us 20.67 degrees. So 20.7 degrees is the theta. And that's it.